Howdy folks, this is Mr. Austin coming at you again with a video with an explanation of our notes that are in this module, as well as the launch for the module. So today we're going to be talking about Module 1, which is called What is a Fraction? And hopefully by the end of this module, you should be able to answer not only that question, what is a fraction, but what are the parts of a fraction and what can those parts tell us? All right, so as you have found out in the introduction to my Canvas videos, the way that this works is I have my iPad side-carded over here. I have everything pulled up. So we're going to briefly go through this. You can come back as many times as you need to. We're going to go over vocabulary. We're going to go over how to show this in models or drawings. We're also going to talk about a real-life application for this, because what is the favorite thing that fifth graders always say? When am I ever going to use this in real life? And when we are learning something hard, we tend to say that more. So this is new for some of us. For some of us, this is old hat, but let's go ahead and get started. So in your Canvas module, you should have a document called Module 1 Notes, What is a Fraction? If you are working on an iPad, you will want to save this document to your files. And I'd like you to have made a file called Math Notes. So I want you to save that to your Math Notes file in the Files app. If you're working on a Chromebook, we will have created a desktop folder and we will have called it Math Notes. I want you to save this to your Math Notes as well. So here we go. What is a fraction? All right. Our big idea of this module is that fractions describe parts of a whole number by telling us how many parts make one whole and how many parts we have. So when we think about numbers and when we think about what they mean, we usually are thinking about their value. We're thinking about how much they are worth. And we think about those in whole numbers usually, okay? However, when we're working with fractions, we really need to change our mindset a little bit. With fractions, we are seeing a number that tells us how many, or we're seeing a representation, rather. We're seeing a representation of A. Okay, so Module 1 Notes, what is a fraction? Big idea of the module. Fractions describe the parts of a whole number by telling us how many parts make one whole and how many parts we have at our disposal. So when we think about numbers and when we think about math, a lot of times we are thinking about the value of numbers. And fractions do have value, but what the point of this module is, and what I really want you to understand, is that fractions tell us what a whole number looks like, okay? And how we could draw it and how we can show it, all right? So let's go through some vocabulary, because I know I just used some phrases that you might not know. So starting off with our vocabulary, we've got whole number. I used whole number in my explanation. A whole number is a set or a number that has all of its parts. When I'm talking about a whole, W-H-O-L-E, a hole, not a hole like a hole in the ground or a hole in the wall. We're talking about a whole as in one whole thing. You're going to hear me say the word whole a lot, like a lot in these modules. So know that that's what I'm talking about. I'm talking about one whole, like one whole hand lotion, one whole cell phone, one whole water bottle. Okay, I'm talking about one whole. We'll also talk about and refer to the whole as a set. And this will make more sense when we get into our models. Some examples of whole numbers are numbers without decimals or fractions. So a whole number could be anything from 0 to infinity. All right. Yeah, 0 is a whole number. Actually, 0 is just 0. But so anything 1 to infinity. So all of our counting numbers, 1, 2, 3, 4, so on and so forth, they are all whole numbers. That means that they all have their sets full. They are whole numbers. Next, we have partial numbers. These numbers are where the sets are not full, meaning that the number does not have all of its parts. So we've been working with some partial numbers already when we've been working with decimals. So 5/10, that means that we have 5 out of 10 parts. Well, that tells us that we have 10 parts to make our whole. We only have 5 of them, so it's not a whole number. Same with 66/100ths, 27/100ths. And then we have some examples here of fractions. This tells us that it takes 2 parts to make a whole, and we only have 1. So those are all partial numbers. They are not whole numbers. All right. And partial numbers always will be shown with a decimal or in a fraction. Parts, you'll hear me talk about parts or pieces. The parts are the pieces that make up a whole number. So when we break things, we say, oh, this broke apart, or oh, this fell apart. If I broke a candy bar in half, I would say I have 2 parts. Okay, so parts are the pieces that make up a whole. Next word is fraction. A fraction is a way to show how many parts a number has, or how many parts a whole number has. I am going to correct myself there. How many parts a whole number has, and how many parts we have available to us. So in our examples down here of 1/2, 2/3, and 27/100ths, we see that well, okay, I need to explain some other vocabulary first, and then we will come back to this. Okay. So our denominator, our next word is denominator. The denominator is the number that tells us how many parts make a full set or make a whole. How many parts make up a whole? The denominator is located at the bottom of the fraction. Okay, so in this example, we have 23/27. In this fraction, the number 27 is the denominator. So that tells us that it's going to take 27 parts, 27 pieces in a set to make one whole. Okay. In our examples up here then, this one, 1/2 tells us how many parts it's going to be made up of to make a whole. That's going to be 2. Here in 2/3, oh my goodness, stop it. I don't want to select anything. I'd like to highlight it. Oh my goodness, 2/3. It's going to take 3 parts to make one whole. And 27/100ths, that's going to mean that it takes 100 parts to make a whole. All right, so that's the denominator. The denominator describes what the whole looks like, describes how many pieces or parts it takes to make one whole. Then we have the numerator. The numerator tells us how many parts are available in a set that we have. It's also the number at the top of the fraction. So when we have fractions, we have, like we said, the denominator that tells us how many parts make up a whole, but then our numerator tells us how many parts we actually have. So I always think of it like this. The numerator is the amount of marbles, or the amount of M&Ms that you can hold in your hand. Okay, so in this example, my numerator is 23. So I'm going to imagine that I have 23 marbles in my hand. The numerator are the parts that you can hold, the parts that you can touch. All right, so 23 is the numerator in this example. Up here in our fraction examples, 1 is the numerator, 2 is the numerator here, and 27 is the numerator here. Okay, now I'm thinking back here and I want to add something. I wonder if I go to markup B. Okay, so if I have, yay, let's add this. We have a fraction that has a denominator of 7. Okay, if I have the same number in the numerator, so 7/7, that tells me that I have a full set. All right, I have 7 marbles in my hand. It takes 7 marbles to fill up a whole set of marbles. So I have 1 hole there. Okay. So the reason I wanted to explain that is because sometimes we'll encounter something called a fraction greater than 1. A fraction greater than 1 is a fraction that has a number that is larger than the denominator, meaning there are more parts than necessary to make a whole. So our example here is 7/3. The numerator is 7, and that's greater than our denominator, which is 3. So that tells us that we have enough parts, enough marbles in our hands to fill up more than one set or make more than one whole. Okay, so according to this denominator, okay, remember fractions tell us what numbers look like, denominators tell us what the whole looks like. Our denominator tells us that that our whole has 3 parts. Well, we have 7 marbles to make some holes with. All right, so can I make one full set? Absolutely, because I have more than just 3 marbles. So I'm going to take those out, put my 3 in there. Okay, now I have 1 hole, and then I still have 4 marbles left. So can I make another hole? Absolutely. So now I have 2 holes, and I only have 1 marble left. Now, can I make a hole with 1 marble? No, I can't, because my denominator tells us that we have to have 3 pieces, 3 marbles, 3 things that we can hold on to make a whole set, make a whole number. But the way that we can show this number 7/3 in a way that tells us that we have whole numbers as well as partial numbers is using what's called a mixed number. A mixed number is a way to show fractions greater than 1 that shows a whole number and a fraction. So I got a little bit ahead of myself. If you need to go back and pause the video to think about that vocabulary, ingest it a little, chew on it, feel free to do so. If you need to go back and watch it again for an explanation, that's cool too. Or if you need to pause and ask your teacher some questions, or an adult or a friend, someone who's going to help you, go ahead and do that now. All right. We're going to talk about models. Okay, models are pictures. When I talk about models, I'm talking about pictures or drawings or how we can visually represent what we're talking about or what we're saying. So these models are types of models that you will see, that you'll be seeing. It'd be cool if I could read what I wrote, right? These are the types of models or pictures that you will see being used in this unit to represent fractions. Sometimes I will call them a chocolate bar. Most of the time I will call them a chocolate bar because who doesn't love a good chocolate bar? If you don't like chocolate bars, leave a comment, okay? And we'll talk, because obviously either you haven't had good chocolate or we need to get you to a doctor. But anyway, so the way that this model works is, if we think of this as a candy bar, okay, and we look at our fraction, whoa, I didn't mean to do that. Our fraction is 1/4, which means our numerator is 1, our denominator is 4. Personally, I always like to look at the denominator first because the denominator describes what the whole looks like. I have no idea how this candy bar is divided up until I look at the denominator. So here, my denominator is 4, which means my candy bar or my rectangle is divided into 4 pieces. 1, 2, 3, 4. Okay, so then we look at our numerator. Our numerator is 1. That tells us how many pieces we have or how many pieces we can hold in our hand. Okay, so if we only have 1, that means we only get to shade in 1. And this shows 1/4. This model shows that there are 4 parts of the chocolate bar, just like the denominator tells us, but our numerator tells us that we only have 1 part. So 1 part is shaded in, making this a model of the fraction 1/4. All right. Next, I have a fraction, another fraction here. So you don't always have to fill these models in left to right. You could do 1, 2, 3, and then fill in this 4th one. Okay, as long as you show me how many parts that you have and how many parts the whole is made up of, that's cool with me. So here I showed you that I did every other one. So my denominator was 7. Always looking at my denominator first because that tells me what my whole looks like. That tells me what the whole chocolate bar is divided up into. So this tells me that I have 7 pieces making up my chocolate bar. So let's count 1, 2, 3, 4, 5, 6, 7. Okay, I have 7 pieces and I have all together to make a whole. And I have 4 pieces that I can hold in my hand. Okay, so I shaded in 1, 2, 3, 4 of them, which means I need 3 more to make a whole candy bar. So this model shows that there are 7 parts to the chocolate bar and that we have 4 parts available to us to use in this set. All right. Now we have a fraction greater than 1. All right. There is no reason to be frightened by fractions greater than 1. And I should have told you this earlier, but in the past, you may have heard these fractions referred to as improper fractions. But what did those fractions do that are wrong? They did nothing wrong. They're just fractions. They're doing their jobs which is to tell you how big the whole is and how many parts how many parts you have. So really, it's just a fraction like any other. So I want you to get in the habit, please, and this is something that I will correct you on, I want you to get in the habit of calling these fractions greater than 1. I will not accept improper fractions as an answer. These are fractions greater than 1. Okay? And the reason that we call them fractions greater than 1 is because the amount of pieces that we have is more than enough to fill up a whole set. So you see here, our denominator is 4. That tells us that it takes 4 pieces to make a whole. 4 pieces in my chocolate bar. And I have 7 pieces. I have 7 pieces in my hand here. So if I'm putting these pieces of chocolate into the slots, well, by golly, I can fill up a whole chocolate bar and then fill up most of a second chocolate bar because I had 3 left over, right? Just like up here. Oh, nope, ignore me. Okay. So I had 4 to fill up this set, and then I had 3 more because I had 7 altogether. Okay. If this numerator was changed to 8, what would I have? Put that in the comment down below. If my numerator here was 8 instead of 7, what would I have here? Put it in the comments, let me know. Okay, so this model shows that we have 7 parts available to us to use and that it only takes 4 parts to make a whole set. Since we have more than we need, once we fill a whole set, we can start filling other sets or another set. So we filled up our whole set. We still had more, so we start filling up another one. Okay, last one. Mr. Austin, that looks awfully familiar. Well, you know what? It's because they're the same number again. So 7/4 means that we had one whole and 3 out of 4 parts left. Or we had those parts in our hands after we made a whole. If we have a mixed number that says we have one whole, right, because that's what it says, and 3 out of 4 parts left, well, then we can show that in a model as well. So I will, again, look at my denominator first. My denominator tells me that I have 4 parts to make a whole number in this set. So when I draw my figures, these are what I call sets. When I draw these, I need to make sure that they have 4 parts. And by looking at this, I know that I already have one whole. So I know that one of them's already going to be full. So I'm going to need a second one. So I draw my second one, both of them having 4 parts. My one whole, fill that in, because if I have one whole, that means I had 4 pieces to put into 4 slots, right? And that made one whole. And then I had 3 left over still. 1, 2, 3. So you could say that 1 3/4 is the same thing as 1, 2, 3, 4, 5, 6, 7/4. You can also say that 7/4 is the same thing as 1 3/4. They're equivalent, and we'll talk about equivalent fractions later. Okay, this model shows that we have one whole set and 3 parts left over to use in another set. All right. Feel free to pause here. I want you to go take your quiz. Go look at the part of this module that talks about models and representing things in models. Get some practice with models, and then come back to this video to the "When am I ever going to use this in real life?" chapter. So, favorite quote by every 5th grader that I know is, "When will I ever use this?" Okay, literally every 5th grader ever has said it. So to quote the great, literally every 5th grader ever, when will I ever use this? Well, here's an example. Lana wants to have pizza for dinner. There are 7 people in her family, and each pizza is cut into 6 pieces. How many pizzas does Lana need to order so that each family member gets a slice? So with Mr. Austin, and you'll have found this out in the introduction module, the way that I approach mathematics, or literally every question or problem that I have in my life, I think about this. What is this asking me? What do I need to know to answer that question? And do I already know that? Okay, so let's look at this word problem and go through those questions. So first question, what is this asking me? Well, it's asking me how many pizzas does Lana need to order so that each of her family members gets a slice? What do I need to know? Well, I probably need to know how many pieces or parts make up one whole pizza. And I also need to know how many pieces Lana needs to feed her whole family. Okay, what do I already know? Well, I already know that Lana has 7 people in her family and that a pizza is cut into 6 slices. So what we're going to do is take that information and we're going to go from there. So when we think about our pizza, we want to think of it as a whole set. Okay, and I'm going to draw a model along with this if you don't want to think of this as a pizza, because you can totally use a rectangular fraction model. Okay, so there's our rectangular model. What do we already know about the pizza? Well, if we're thinking about our pizza as a whole set, what do we already know about the pizza? We already know that the pizza is cut into 6 slices. So one whole pizza has 6 parts. 1, 2, 3, 4, 5. Is that 6 pieces? 1, 2, 3, 4, 5, 6. Yes. Okay. And we know that Lana has 7 family members. Okay, let's make our dots green. Why not? Okay, 7 family. Oh, it's still black. Boo, boring. Anyway, 1, 2, 3, 4, 5, 6, 7. Okay, so we have 7 family members. Okay, so Lana, Lana calls out the pizza place. She goes, beep, boop, bop, bop, beep, beep, boop, bop, bop. Hello, pizzas? Yes. How many pieces is a large pizza cut into? And the pizza expert goes, well, miss, our delicious handcrafted, mouth-watering pizza pies are cut into 6 pieces. All right. So Lana now knows that one whole pizza is in 6 pieces. We knew that already. So one whole pizza has 6 parts. Lana wants everyone in her family to have one piece of pizza, but there are 7 people in her family. 1, 2, 3, 4, 5, 6, 7. So that's a problem, right? So we're thinking we want to have 7 parts, but each whole is only made up of 6. We need 7 parts of this pizza, but each whole is made out of 6. So we have a fraction greater than 1. All right. So to use a model, I'll show you here. We have 1 person, 2 people, 3 people there, 4 people, 5 people, 6 people here. But then we have 1 person left over. So since our whole is only made up of 6, we need to have another whole. Oops. Oh no. Oh no. We need to have another set to get this person a slice of pizza. All right. So here we go. Oh my gosh. 1, 2, 3, 4, 5. Because they needed a whole other pizza just for this one person. You know what I'd say? I'd say, Kevin, you can have a peanut butter and jelly sandwich, but whatever. So we now have a fraction that shows our problem. Each rectangular fraction model represents 1 pizza. We have 1, 2, 3, 4, 5, 6 parts to a whole. There are 1, 2, 3, 4, 5, 6 pieces in a pizza. So that's why our model has 6 pieces. We have 7 family members. 1, 2, 3, 4, 5, 6 of them could eat off of the first pizza. And Kevin, just because he had to have pizza too, has 1 slice on the second pizza. Then they have 5 pieces left over. So I guess that's okay. Lana can take it for lunch. Lana can take it for lunch tomorrow. So 1 whole pizza had 6 parts. Lana wants everyone in her family to have 1 piece of pizza, but there are 7 people in her family. Since the pizzas are cut into 6 pieces, how many pizzas did she need to order? Well, Lana needs to order 2 whole pizzas. Okay, 1, 2, so that she has enough pieces to feed her family. All right, 6 pieces make 1 whole pizza, so our denominator in this case was 6. There are 7 people who need to eat, so there needs to be 7 parts in the numerator. We would write this fraction as 7 over 6, or 7/6, making it a fraction greater than 1. Okay, Okay, and then I had a fun little model here, down here, of the pizzas. So each pizza had 6 pieces. We were able to feed 6 of the family members with 1 pizza, and then Kevin had his own piece over here. Okay, so again, that's the end of our explanation and our module here, our notes here. Everything that I expect you to be able to answer has been covered in this module. Remember, at the beginning, I wanted you to be able to tell me what a fraction is, what parts there are to a fraction, and what fractions are telling us. Okay, so I think we should be able to answer those 3 questions if we're using this video the way that we need to, as well as asking questions as we come to them. So this video has chapters. It'll be chapter titled in the 3 different areas. So actually, you know what? I think I'm going to do vocabulary as each word or each phrase, so that you don't have to sit through the whole vocabulary thing. So there will be a chapter for whole number, partial number, part, fraction, so on and so forth. And then I'll just do models and our favorite quote ever. When will I ever use this? Okay, so I hope this video is helpful for you. Remember, please, 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 math is not about getting answers. It is about understanding how we got to that answer. So take a deep breath. Repeat after me. I am someone, and I will be a better someone when I leave here today, because I am the change that this world needs. All right. Go and be brilliant, friends.